All right, graphs of logarithms. This is a follow-up video to another one that I did where I introduced graphing of logarithms. But I want to kind of dive in a little deeper as far as the symbolic representation and how we can analyze that to graph logarithms. So first off, here we have a basic logarithm, and that's of the form y equals log base A of x. I'm not specifying the base because the general shape for this basic logarithm is graphed like this. The only thing you really need to recognize is two things. One is all logarithms pass through the point 1, 0, and they have the y-axis as a vertical asymptote. In other words, this graph, as it heads down, is getting closer and closer to the y-axis, but it never touches the y-axis. So the y-axis is an asymptote. So when you're doing these problems, let me just do a couple in your homework, or problems like your homework. So here we are. Oh, that's not it. Here we go. All right. So the first question here is asking you to match the function with its graph, and we just have a basic log function. The base is 3, and just like I've graphed here, you're looking for that basic shape of a logarithm, which is b. Okay, so that's good. The next question, again, you have to be careful now. This particular logarithm has a fraction instead of a whole number, or a number greater than 1, I should say. So when you have a base like this, you've got to be careful. Let me go back to the board and show you what you need to consider when you do that. So, so here we have our equation. We want to graph y equals log 1/6 x. And I want to deal with the fact that this is less than 1. Okay, well, in order to manipulate this symbolically, I'm going to put it in exponential form. So remember the log, so the base is on the bottom. So I've got 1/6. The log is the exponent, so y is the exponent, and that will equal to x. Now, the reason why I've written it like this is because whenever you have a number less than 1 raised, like 1/6 in this case, you're going to recognize that this is the same as 6 to the negative 1. 1/6 is just 6 to the negative 1. And so I really have 6 to the negative 1 raised to y, and that's our x. And now when you raise an exponent to another exponent, you multiply. So I have 6 to the minus y equals x. And now I'm going to go ahead and put it back in logarithmic form. So remember, the base is, so the log is the exponent. So we have log, the base is on the bottom, 6. The exponent is minus y, and then what's left is x. The log is the exponent. So now, writing it like this, I'm going to do one more step. I'm going to divide out by a negative and switch sides. It's 2 steps, but so I switch sides. Y equals log 6x, but it's really minus y equals log 6x. So I'm going to multiply both sides by a negative to move that minus. Now that I have it in this form, notice when you have it, when you go from this form to this form, you get an extra negative out front there. When by flipping the base, instead of 1/6 and writing 6, I have a negative. This means that I'm going to reflect across the x-axis. So if I graph this function, the x-axis whoops, I'm doing the wrong, I'm thinking of something else right now. Okay, so this point is on the x-axis, so it's going to stay fixed. And then this side, what's negative, is going to now become positive, so it's going to come up like that. And then what was positive is going to be negative, right? Because I'm reflecting it. Okay, so the graph is going to look like this. So whenever you have a base with a fraction where it's less than 1, you're going to have this sort of reversed, it's going to be reflected across the x-axis, so be careful about that. So if we're looking here, I'm going to share my screen so we can go back to that homework that we were looking at earlier. Okay, so because I recognize that this base is less than 1, I know my shape is going to look like this. It hasn't been shifted or it's only been reflected. So here again, the base is E. E is approximately 2.7. So I know it's gonna, it has not been reflected across the x-axis. So I'm going to look for that classic logarithmic shape right here. We can see that. Okay. Okay, now we are starting to get into the shifting. Okay, the base is 2, which is greater than 1, so it's going to have the classic logarithmic shape, but it's going to be shifted to the right by 1 unit. So you can see that is exactly what happened here. Here we have that basic logarithmic shape. This would not be correct. This is the one that has been shifted to the right by 1 unit. So that is the correct choice. Here, now the 2 is on the outside of the logarithm. In the previous one, we shifted to the right because the -1 was inside the logarithm, but this 2 is outside, so this one is going to be shifted up 2. But we still have that basic logarithmic shape, and it's been shifted up 2. So we can see D is the correct choice here. It's got the shape as I have here on the board. That basic logarithmic shape, but it's been shifted up 2 units, so D is the correct choice. And let's see, I've included a lot of examples here so we could really nail this down. There I recognize right away, oh, that's a fraction, 1/5. So I'm going to have that reflection across the x-axis, and then it's been shifted to the left 3 units because the 3 is inside the logarithm, so that's going to be a horizontal shifting, and it's +3, so that means it's to the left. So I can see that B, it looks like B has been shifted 4 units. Let's look at this graph here more closely. Yes, this is the graph. You can see the point, it normally would pass through 1, 0. It's been shifted 1, 2, 3 units. So right to this point here. So this looks like the correct one. And that is C. All right. Finally, we have a reflection across the y-axis because the negative is inside. Now, if this 4 had been 1/4, let's say, then we would have had 2 reflections, one across the x and one across the y. But because that's greater than 1, we only have the reflection that's horizontal because it's inside the log function. And so it's going to be across the y-axis. And we can see this basic shape here that I've drawn in black reflected across the y-axis is going to go on the left-hand side as D is showing right here. So I hope going through these examples has helped you understand about how we do these graphs. Reach out to me if you're struggling with any of this content, and I'd be happy to help you.